Hello to my logic class. I hope you're having a great day or a great week. This is me before the snow and ice comes. So I wanted to help you guys work through a review of chapter 6 so that we're ready for our test. Sorry, I'm squinting. It's very sunny. Also, this is my neighbor's cat who comes to visit me on my porch. And I know you guys like animals, and we have a lot of syllogisms about cats, it seems like, in our class. So there you go. All cats are blank. What would you do? What would your syllogism be? Anyway, okay, let's start reviewing, and I'm hoping I can stick a little picture on here if I'm super cool and techy. Otherwise, just imagine it. Okay, so first we want to review the square of opposition. That will be on your test, even though we're talking about relationships of equivalence instead of relationships of opposition. We still want to remember those, and our square will help us know what type of syllogism we have. So if you look at the square of opposition, either in your notes or right here, you will see that on the top left corner is the A proposition, which A is for all, and that syllogism or proposition would read, all blank is blank, okay? It's positive and universal, okay? And then on your right-hand corner, you're going to see the E proposition, which is the universal negative. So what does that mean? Correct. It would read, no blank is blank. Okay, so you have a negative word of no in there to make it negative, and then it's talking about all of those type of things, and so that's what makes it universal. Okay, let's move down to the bottom left, which is the positive particular. Okay, affirmative, particular, affirmative. So those would read, some blank is blank, okay? And what the blanks are is your subject and your predicate, okay? And then on the bottom right corner, you're going to see your negative particular, which would read how. No, I'm sorry. You could start with no, but let's not do that. Some blank is not blank. So your negative is not. You wouldn't say no. You wouldn't start with no, because that's talking about all of the thing, the item. So if we're saying no cats are at their own home right now, but they're sitting on my lap taking a nap, we say some cats are not at home. Or you could say, is there another way for us to say that? I can't think of another. Okay, let's keep going. Let's not get hung up on that. Okay, let's move on to relationships of equivalence. Okay, we have 3 types of relationships of equivalence. For our test, you will only need to know the names of what those 3 types are, and the only one that we will really be focusing on is conversion. So the 3 types of relationships of equivalence are obversion, conversion, and contraposition, which we didn't really do much on. Okay, there's 2 main purposes of the relationships of equivalence. When we play with relationships of equivalence by switching things around, it helps us to clarify a more confusing proposition, and then it can also help us examine our propositions from different angles, okay? These are going to be on your Quizlet, so those are something that you can remember for that. But the important thing that I want you to remember is that when we are working with converting propositions for conversion, right? Converting, what we're going to do to find a relationship of equivalence is to switch the subject and the predicate in that proposition. Okay, let me see if I have an example here. Okay. I just ate a banana, so perfect. All bananas are fruits, okay? What type of proposition is that? Where does that fall on the square of opposition? That's right. That is an A proposition. So here's my question for you. See if you can get this right. Can you convert an A proposition? Can it be converted for a relationship of equivalence? No, it cannot. Okay, there's only two types of propositions that can be converted and still remain equal. Okay, those types of propositions are the E proposition, which you remember is in the top right-hand corner of your square. The E proposition is the universal negative. So here's an example. No cockroaches are fruit. Okay, no cockroaches are fruit. Let's convert that, since that's one type of proposition that we can convert for a relationship of equivalence. So the subject is cockroaches. The predicate is fruit. Okay, we're going to convert that by switching the subject and the predicate, and then we're going to ask ourselves, is this equivalent? Does it mean the same thing? Okay, no cockroaches are fruit. That's our original. So if we convert that, we're going to switch the subject and the predicate, and we will get no fruits are cockroaches. Okay, is that equivalent? Is that equally true? And does it mean the same thing? Yes, good job. Here, I'll show you my cat again because I know you're getting bored. It's not my cat, by the way. It's my neighbor's cat. Okay, I'm not claiming it. We haven't seen her for a while. She's been at home, but she comes to visit when it's sunny. Okay, the other type of proposition that we can convert is an I proposition. So where's the I proposition on your square of opposition? A, E, I. Yeah, so I don't know how I'm going to do this, but on the right-hand bottom side, okay, it's the positive, it's the affirmative or positive particular, okay? So here's an example. We're still doing fruits. All of these are about fruit. Some avocados are fruit. Okay, so the truth claim in that is that some avocados are fruit. We're not even claiming that all avocados are fruit. Not sure why, but that's what the a priori truth for that is. We're going to convert it by switching the subject and the predicate. So the subject is avocados and the predicate is fruit. Some avocados are fruit. Okay, we're going to switch it around and we're going to say some fruits are avocados. Okay? Does it mean the same thing? Some avocados are fruit. Some fruits are avocados. Is it equal? Is it equally true? Okay, is it the same claim? Some avocados are fruits. Some fruits are avocados. It is. It does. Both of those are true. Okay, you could argue that you're saying different things because if you have your little, if we do the box style, we're saying avocado. We're switching the boxes. So we're saying some avocados are fruits. We don't know if some other avocados are not fruits. Or for our box, we could have a box of fruit and say some fruits are avocados. Some other fruits might not be avocados. So some of the fruits that go in that box might not be avocados. But in the same way, the same central truth is true, that some avocados are fruits and some fruits are avocados. Okay. Now let's try to convert a negative particular proposition, which is the O, A-E-I-O. Yeah, that's on the bottom left. I don't know. So that's our negative particular. Some foods are not fruits. Okay. Do you understand? You could draw this out if you want, if that helps you visualize it. You could draw it out and see that maybe a box that is labeled foods, and you can show that some of the foods in that box are not fruits, okay? Our claim is that not all foods are fruits, okay? Fruit does not make up the entire body of what we're calling food. There's other types of food, okay? That's our claim. So that's our negative one, and this is an O proposition, which you should not be able to convert, okay? And so we'll work through that by switching the subject and the predicate from some foods are not fruits, okay? If we switch that, we would say some fruits are not foods. Does that have the same meaning as some foods are not fruits? No. Good job. I hope you said no. Because if we say that some foods are not fruits, that means that there's other foods that just are not considered fruit. If we say that some fruits are not food, that would mean a totally different thing. That would mean that there are fruits that are inedible, that are not made to be even food. It means something different. Whether it's true or not, it means a totally different thing. That's defining fruits as whether they are even food or not, or if there's fruits that do not fall into the category of food. But our original was that some foods are not fruits. So it's a totally different sentence. Okay, so what you will have to do on our test is to write your own propositions. So you can practice this at home. You can get a sheet of paper and write an A, E, I, O proposition for each one, and then try to convert it, and then try to show whether it works or not. Okay, and if you have a reason for why it does not work, that will help you on your test, because you'll have to do this on the test. You'll have to convert and then show whether or not it works. And it's good to just keep that rule in mind that only the I or E propositions really work. But that's something that's really important for this test. You will also need to know, since we're reviewing, we had gone over in our last worksheet, and I gave you the answers. I sent you the answers. In our last worksheet, we had gone through the word imply. We've talked about the word imply. So knowing that definition is important. And it says that the word imply comes from the Latin word implicare, which means to involve. Okay, so to imply is different than to state something outright. So that's important to know, that if something is implying something, it's just, it's almost like just involving this thing. Like it's connected to the thing, but it's not saying something loud and clear, if that makes sense. So that's important for you to have a definition for that. And then you'll have to know the definition of logic, which I think you all know. But if not, it is the art and science of reasoning. And here's my neighbor's cat again. She doesn't want to look at you. And you'll have to know the definition for a priori. What does a priori mean? Oh. And what else is, I have one more definition. I'm going to have to look through it. But this will all be on your Quizlet. So I'm going to have to go because my daughter's out here saying something to me, and I can't read it. Lisa was helping me out. And the other word that you will need the definition of is truth value, which we have gone over that in previous chapters. So I know you know the answer to that. You will also have to know the difference between a relationship of opposition and a relationship of equivalence. So if you can put that in your own words, or if that's in your glossary, that may help you, because that's something that you'll have to explain on the test. A relationship of opposition versus a relationship of equivalence. And the basic idea for that, I would say, is that a relationship of equivalence is helping you to understand a proposition by switching it around. And it shows a positive relationship. Whereas a relationship of opposition, which we did in chapter 5, is showing a disagreement or a dissonance that you have with someone. Opposition means that you oppose one another in a little way or in a large way, whether it's complete or partial. You oppose the other person, and those are the arguments that are going to be involved in a debate. I hope you all have a great snow week and happy studying, because I know you're going to be studying logic for the majority of your week.